And the question is whether we should also. And if I press escape, it can go down.
Okay.
Should we go and get the people or what? Patients come.
Yeah. Because I switched, I deliberately switched the founders. Oh, is it? People get confused. It's just not me. I'm not doing it. No, people know. It's some name like.
Yeah. Just be ready. I think we should be starting now.
Well. Yeah.
It's 1 minute, thanks. Isn't it 1:30? We should start.
It's according to that clock.
Yeah.
Yeah.
I'm not sure if we should rush people to come in. Or we'll have to push it a little bit into the lunch break. Shift everything.
I mean, here we go. Or somebody should be clapping in for their getting the sheet moving. Were you looking for rights?
Okay, tomorrow.
Yeah.
So are people on the way or not? I'm not sure if we should sort of shift the session of another 5 minutes or what, because very few here. And then we'll just have 5 minutes shift, like everything. I don't think I want to start on time, I'm afraid. Yeah. Well, we'll have to, eh?
Yeah.
Okay, good morning for you guys who are here. Great to see you. And if I should tell anybody off to respect the time of the program, it should be the ones that are not here. So I won't tell you off. We already shifted now 5 minutes. Got 1 more minute if we want to. So I'm thinking this continuation of this morning program will be shifted 5 minutes. Will it be okay? I'm here to chair the second half of the layered intrusions session. These following 4 talks, and then there will be 1 keynote speaker before lunch. But that's in the other session on. I have my glasses. Chromite deposits, and it will be Marianne Holness who'll give that the keynote speaker, and hopefully there's a chair for her, or I can also chair you if you want. Won't make much difference. Yeah. Yeah. All right. So let's get started, and we're going to start out with Robert Trumbull, who is giving a presentation that's actually first authored by Ilya Veksler, but he had visa problem and couldn't come here. So this will be on modal variations in mineral chemistry in the upper half of the main zone. Okay, the floor is yours, and everything should work.
I'm sure everything will work. Hello, everybody. Yeah, Ilya is very sad not to be here, although he's online. I hope so. Hello, Ilya. Hope I can present your work as we've described it before leaving Potsdam. Yeah, so I'm going to be talking about a project which is running in the framework of the ICDP Bushveld project. The ICDP Bushveld project itself will be presented later on this week by Freddie Rolofs on Thursday. But I can just say that the drill cores we're looking at here are in that project, and we've been looking at the main zone. I should also point out, I don't think Dieter has here yet. My colleagues from the BGR, it's one of these things. The first slide you spell the name wrong of one of your co-authors. So Dieter is Dieter Rammlair and not Rammlair. But he's not here, so I'm going to go right to the next slide. There's 2 areas of drill core which are in the Bushveld project. One is on the northern limb. These are completely donated cores. And on the eastern limb, we have a core donation of about 6,000 meters stratigraphy from the Marula Impala Platinum Marula mine that covers the upper zone down to the mid-critical zone. And new drilling in the ICDP project is hopefully will starting in September, is going to continue that profile from the critical zone down to the base of the intrusion. As I said before, don't miss Freddie Rolofs' talk on Thursday at 3 o'clock, talking about the Bushveld drilling project. And you can also, anybody can approach me or Freddie or Sue Webb, who is here, if you want information about this project. We were motivated in this research project, which is funded by the German DFG, by this study on the Bellevue core, which is in the northern limb, shown. I guess I have a pointer here. I don't really northern limb. So that's located here, the Bellevue borehole. Motivated by this study done by Ben Hayes, Lou Ashwell, Sue, and Grant Bybee from Wits, where they did some, well, there's been some density measurements, very detailed density measurements along the main zone in this core, also the upper zone. Here's the border of the upper and main zone on the middle of the left-hand panel. And you can see these kinds of upward increasing density intervals, which is perhaps contrary to what we would expect if it's a normal differentiation sequence where things tend to get more felsic upwards. The density should actually decrease. And these cycles of increasing density were interpreted as intervals of magma recharge, perhaps in frame B here, where a more dense magma intrudes as a sill, whatever, however it intrudes, and that material percolates downward into the pre-existing mush, causing this upward increase in density. And this cycle repeats itself, so that possibly these kinds of density measurements on a drill core could actually show this kind of cryptic layering. Well, we wanted to do the same thing for the main zone, which is in the cores donated from the Marula mine on the eastern limb. And Ilya went to South Africa after lockdown was allowing it and sampled about 1,350 meters of the main zone at 5-meter intervals, measured the density of those those samples, and then made thick sections of the drill core to bring back to Germany. You can see them glued onto little plexiglass strips here. So the methods that we're applying in this study, that I'm going to show now, are basically the rock density, and then taking these slabs to our colleagues in the BGR, looking at the modal mineralogy and some of the mineral chemistry variability with LIPS and with the micro XRF tornado. First result, on the right-hand side, you see our density measurements. It's a little bit difficult to correlate this section with the Bellevue core, first of all, because there's no peroxenite marker in that core. But we do know from the drill logs of the Marula mine that the upper zone, main zone boundary is about 500 meters above where we started to sample. And if you look at the upper zone, main zone boundary over here in Bellevue, maybe this amount of section might be above here. So maybe this is roughly comparable to what we see on the left on this diagram. And the point is, of course, we don't see these zigzag sawtooth density changes, except possibly here at the bottom. We see a much more subdued, much more regular profile. We have taken this profile now and just look at it over here. We've connected the dots with lines. And we're identifying these zones for our purpose to go into more detail. The upper zone here being very strongly marked with density contrasts. And we have to remember that the main zone consists basically of two types of minerals, plagioclase and pyroxene. So the density contrast is just is reflecting a modal contrast, obviously. So there's large modal changes in this zone. Here's the peroxenite marker. You see things going up and down. But when we get into this middle part, very little is happening. Maybe a bit of plagioclase-rich horizon here, less dense. And in the bottom zone that we've got here, you see a couple of these possible cyclic incursions as was reported from the Bellevue core. So the next thing we've done is to look at mineral modes. This is an example on the bottom of a map done by Tornado with the minerals identified and mapped according to mineral libraries acquired by the BGR colleagues. So you can see that the rock is about 98%, 97% composed of these three phases. To sort of verify this, we've taken and plotted the plagioclase mode from that slide for all the samples against the rock density. And it looks like there's a good correlation. First, it tells us that the rock density, of course, is reflecting the mode. And also this correlation here shows that the calculated mode is pretty much correct. The plagioclase, pure plagioclase would be down here at this point with something like 2.6, 2.7. Grams per cubic centimeter. So we think the modes are reliable. We're going to be using those now to make some preliminary inquiries, suggestions interpretations, you might want to call them. First thing that Ilya has done is to take melts and calculate what the modal proportion of plagioclase should be using a B2, I would think, liquid. At different pressures, you get different modes of plagioclase, but the 3 kilobars, which might be more or less realistic for Bushveld intrusion level, at that level, the plagioclase is always cotected with pyroxene and it never gets above about 50%. This is what we're seeing in the average mode of all those points you saw in the previous slide. So it looks like we have too much plagioclase. And the simple interpretation might be we're seeing evidence that whatever magma was contributing to this interval of the main zone could have had suspended plagioclase crystals in it. The next thing is chemical composition. And this is done by LIPS, by laser-induced breakdown spectroscopy. And this is calibrated with electron microprobe, and BGR has a lot of experience and a lot of publications justifying that. I'm not going to go into them, but there's a couple talks by the team here, by Nikonov and by Rammlair, and you'll see more on those techniques later. The point here is, first of all, this is an extremely powerful method to do 1,000 meters, 1,500 meters of core without making 15,000 thin sections. So that's the one message. Please be aware that there are techniques that can give you quantitative, or let's say good semi-quantitative anorthite numbers for plagioclase, magnesium numbers for CPX and OPX. And this plot shows now those two parameters in vertical sequence. And you'll notice that the plagioclase is not doing very much in terms of vertical lines, except of course there's a lot of variation above the peroxenite marker, but we know that that's a recharge event and there's a lot of interest up there. But look at how the variation in clinopyroxene and plagioclase are not parallel. So something is happening on a regional scale with clinopyroxene getting less magnesium going up, plagioclase more or less not. To summarize these density and mineral compositional things, we have these zones, and we think that there's, as I say, a lot of monotonous things in the middle zone. This is actually something which we find very interesting because there's nothing happening. But that's not to suggest that we believe this is a 700 feet or 50 meter zone of one magma event. Rather, it looks like this subzone B, as we're calling it, must be assembled by magmas which have a similar composition, and they're just not showing up in density or modal variations or so much in the mineral compositions. As a detail of other things that we're trying to interpret from this data set, you can plot things like the modal amount of pyroxene against the magnesium number, and you can see that the samples that have low magnesium number are also those samples that are richer in plagioclase. So we think that this shift to low Mg number in pyroxene is reflecting the interstitial liquid interacting with a rock that is dominated by plagioclase, whereas there's not much variation in that sense in the main thing. So this could be the trapped liquid shift effect, changing the CPX composition in rocks that are dominated by plagioclase. So I'm going to wrap it up just with a couple of quick conclusions. This is ongoing work. We haven't really gone into the mineral chemistry. We're planning to do some oxynoisotopes. The idea was to find these zones of recharge and then look at them in detail. Is there a temperature variation? Is there a variation in the incompatible elements that might tell us what kind of magma is coming in? But what we've done so far and what I present here is just this first glance, and to make the point really that these scanning techniques should be used, I think, more often. They provide robust mineral modes and useful chemical parameters, and you can conclude a lot from them already, but they are wonderful guides to say which intervals you want to do more work on. We have the three zones. We've seen those before. The topmost zone with the peroxenite marker is, as I said before, something that people have looked at for many years. And on these particular cores, there's a group in the University of Free State with Justine Magson, who have published on the peroxenite marker and the rocks immediately above and below it. And you can go to Justine's talk on Thursday at 2:15 and hear that information. We talked about the subzone, which is monotonous, and how we don't have this kind of cyclic variations, or we don't see them. Gravity is not showing them. But we don't think that it's a single batch of magma. We think there must be. It can't be assembled from a single, 1,000-meter thick magma liquid. But we think there must be something happening there. But if there is recharge happening, it's not coming from a stratified chamber off stage. The lower zone looks like it might be similar to the Bellevue core. We're going to look at these cycles that we've seen there and see what's going on. And as I said, using this quick method of scanning and obtaining a modal data from 1,500 meters of core in a matter of a couple of weeks lets you make some inferences about what's happening at a large scale. And we think probably whatever the main zone in this particular place represents, it was probably a suspension of plagioclase coming in because we just see too much in the rock today. And finally, I thank Freddie Rollis especially, but also Justine. Here's Freddie logging the donated cores. This is the UFS. This is part of the Bushveld ICDP project, and it's available to researchers worldwide, including yourselves. So inform yourself about the Bushveld project and get involved. Thank you very much.
Thank you, Rob. Interesting. We have time for some questions.
Couple of things. I looked at the strontium isotope variation in the Bellevue core and in the BK core boreholes. It's the same up to in the Bellevue core, it's all upper zone compositions up to the bottom of the core, which is a troctolite type layer. And in my view, that troctolite layer is the direct equivalent of the peroxenite marker. So that entire Bellevue core is above the peroxenite marker. The second thing is, I wrote a paper in, I think it was 94, somewhere around there, in which I would want to put the base of the upper zone at the peroxenite marker, essentially. So these two are completely different magmatic systems. The peroxenite marker is a very, very important layer that separates one magmatic system from the other magmatic system. Thanks.
Yeah, I'm aware of this question about stratigraphy, and I don't want to get into it. What I do want to say is, putting Bellevue aside, this was one of the reasons we did the project, because we thought, let's look at this. Can we find what is happening in this monotonous gabbronorite? What is it? The main zone is so boring, and it's such a apparently homogeneous drill core. Well, excuse me for saying that, but we thought we would look at this thing using this method and see what we see. And so one of the tools that seemed to be available was this density thing. That's something that can be done on a semi-continuous scale with relatively little effort. And the other thing that we were benefiting from with our colleagues in Hanover is this drill core scanning thing that we also wanted to check out what the potential is for that. Whether or not I can compare this particular section on the right with that particular section on the left in terms of the definition of upper zone, main zone, boundary, etc., I yield. I don't want to get into that. I think some people would have it one way and some people would have it the other way. I'd prefer not to comment on that.
Okay, I think we have to cut it short here. We're already pushing the time in, so let's have the next speaker. If I can find that.